All right, 2.8, absolute value function. Your goal or objective for this section is to sketch the graph of the absolute value equation. Homework for this section is 20 through 26 in the homework packet. All right, let's look at the first example. What we want to do is fill in the table for the given function and plot the points on the graph. So let's go ahead and do that first. So we have f of x is equal to the absolute value of x. So when we remember, absolute value is the distance from 0. So it's the distance the number is from 0. So if x is 0, y is 0. So the absolute value of any number is going to come out positive. So if x is negative 1, y is positive 1. If x is negative 2, y is 2. X is negative 3, y is 3. X is negative 4, y is 4. Now we do the positive values. 1, 1, 2, 2. Then we have 3 and 4. So if x is 3, y is 3. If x is 4, y is 4. So we're just going to plot the points. 0, 0. When x is 1, y is 1. When x is 2, y is 2. X is 3, y is 3. X is 4, y is 4, and so on. So let's look on the left-hand side. When x is negative 1, y is 1. X is negative 2, y is 2. X is negative 3, y is 3. And x is negative 4, y is 4. So we have this graph which we call the parent function. It's the main graph. It should be right at 0 in this case, but it moved over a little bit because of my pen. So that's the graph of f of x equals x. The vertex is at 0, 0, where they both meet, both rays meet at 0, 0. All right, let's go to the next one. It says, go ahead and graph f of x is equal to the absolute value of x plus 2. So let's go ahead and put those in. So if I have 0 in the absolute value of x, is 0 plus 2 is 2. When I put negative 1 in, I get 3, 4, 5, and 6. So all I'm doing is adding 2 to the absolute value of that number. So then we go the other way. 1 is 3, 2 is 4. 3 is 5. And 4 is 6. So let's go ahead and plot the points and see what happens when we add 2 to the graph. So 0, 2 is right there. 1, 3. 2, 4. 3, 5, 4, 6. On the other side is negative 1, 3, negative 2, 4, negative 3, 5, and 4, 6. So when we added a number to the absolute value of x, what happened? Well, when we add 2, it moved up the vertex 2. It moved up. The whole graph moved up 2 units. If you had f of x equals the absolute value of x minus 4, the graph would move down 4 units. Okay? So the vertex would be down to here, and then would go up this way, if you look up there. So whenever you have something adding to the absolute value or subtracting, adding moves the vertex up, and subtracting means it's going to move down the vertex by that many units. All right, let's go ahead and look at this example. F of x, so we're going to graph the points. F of x is equal to x minus 2. So this is y here. So let's see what happens. So when we put the value of x as 0, y is 2. When we put the value of negative 1, y is 3. Negative 2 is 4. And then go in the opposite way. Y is, when x is 1, when x is 1, put the wrong one there, sorry. When x is 1, y is 1. When x is 2, y is 0. When x is 3, y is 1. And when x is 4, y is 2. So let's go ahead and plot that. So 2, 0 is right here. 1, 1. 0, 2. Negative 1, 3. Negative 2, 4. 3, 1. 4, 2. 5, 3. And 6, 4. So when you have a number subtracted from x inside the absolute value, it moves, in this case, 2 units to the right. The vertex moves 2 units to the right. 2 units to the right. I'm going to leave example 4 for you to do. But what I can tell you is this negative in front of the x flips the graph upside down. That's a good hint for you. Flips it upside down. All right, so this is the general form of the absolute value function. Right now we're just going to focus on if a is positive or negative. If it's positive, your graph is going to go up. If it's negative, the graph's going to turn upside down. The absolute value. Okay? H, if the number inside is being subtracted, it moves to the right. If it's being added, if it's x plus a number, it moves to the left. The whole graph moves to the left. The vertex moves to the left. K moves up or down. If K is positive, the vertex moves up. If the K is negative, vertex moves down. Okay? All this stuff is what I've already talked about. So let's look at an example. Graph the absolute value function without plotting points. All right, so we have a negative absolute value plus 1. The plus 1 is going to move the vertex up 1 unit. So plus the negative means it's going to be upside down. So we're going to move up 1 unit. Here's the vertex. And it's going to be down. Okay? It's going to look something like that. I didn't draw it straight. Okay? It's going to look like that. It's going to move it up 1 unit. Now the domain with absolute values is it's always going to be all real numbers. The range is y is less than or equal to 2. All the y's have to be less than or equal to 1. However high the vertex is, all the y's are less than or equal to 1. Let's do one more for you. All right, so in this example, we're subtracting 2, so the vertex is going to move down 2 units from the origin. Okay, so the vertex moves down 2 units, down 2 units. Okay, the domain, again, like I said, with the absolute values, the domain is all real numbers. You can put any value of x in there and you'll get y's. But the range is y is greater than or equal to -2. You always use the vertex. If it's opening up, it's going to give you greater than. If it's opening down, it's going to be less than. I'm going to go ahead and leave the other examples for you to try. If you have any questions, I'll get in hold of your instructor.